Hi, my name is Anil Nair, and I'm an aerospace engineering student here at UCLA. And I'm going to help you by going over some math concepts and examples. Good luck.
The example video for monotonicity and concavity. So for the first example, we have y equals 3x minus 1 to the 1/3 power, and we're going to determine where y is increasing, decreasing, concave up, and concave down. And then using this, we'll make a quick sketch to show you what these things. So to find out where it's increasing and decreasing, we need to put the derivative. So y prime, that's going to equal 1/3 3x minus 1 to 1/3, to the negative 2/3 power. And then using chain rule, we get 3. So these 3's will cancel. So y prime is just 3x minus 1 to the negative 2/3. And we can write that as 1 over 3x minus 1 to the 2/3. So we can see that y prime doesn't exist at x equals 1/3 if we set the denominator equal to 0. But otherwise, y prime is always going to be positive. So it doesn't exist at 1/3, but otherwise it's always positive. And this is a sine graph to show you what sign, positive or negative, the function takes, or the derivative in this case, as we increase in x. So this is as x increases. So always positive except at 1/3. So we are increasing, or so y is increasing on the interval negative infinity to 1/3, and the interval 1/3 to positive infinity. And these are open intervals because we're not touching 1/3 or positive or negative. So as we can see, y is not decreasing at all. And now we take the second derivative to check the concavity. So negative 2/3 3x minus 1 to the negative 5/3 times 3, chain rule, so cancellation. We have negative 2, and we'll just write this as negative 2 over 3x minus 1 to the negative 5/3. So again, y double prime doesn't exist at x equals 1/3. But unlike before, where we had a squaring of the denominator, here we are, and this should be positive. Sorry. We have the denominator taken to an odd power and then odd root, so we can get positives and negatives. So we plug in a large positive number, for example, 3x minus 1 to the 5/3 will be positive. But we have a negative up top, so we'll get negative numbers past 1/3. And if we put in a really small negative number, like negative 100, we'll get a negative in the denominator, which will cancel with the negative in the numerator to give us positives. So this shows us that y is concave up on the interval negative, and sorry, this should be closed interval, or open interval, negative infinity to 1/3, and y is concave down on the interval 1/3 to positive infinity. So if we used all these things to sketch a graph. And you don't have to do this. It's just to help us visualize what's going on here. So y prime is always increasing, but it's concave up until 1/3. So draw 1/3 here. So it's concave up, so it's probably going to look something like this until we get here. And then it's concave down, but still increasing. So we're going to get something like that. And in fact, there's actually a vertical tangent line here. That's why y prime doesn't exist at 1/3. So yeah.